Okay, so today we don't have any totally brand new ideas, but we're going to apply some other ideas. It is January 9th, 2013. We are still talking about polar coordinates, and we are going to talk about them in a much darker color, because that was too faint. Conversions. Now, first, where polar coordinates actually came from. We talked about that a few days ago, so I'm not going to go back from scratch, but maybe I'll go back a little ways. If you talk about any point, I'm just doing quadrant 1 sort of at random, this can be any point anywhere, it will have a distance from the origin that we've been calling r. It will have a standard angle from the positive x-axis, which we've now been calling the polar axis. And if we go back to rectangular coordinates, it will also have an xy coordinate. And when I first introduced these, I went through some of the relationships that these have, and I'm going to start. We're going to expand on those a little bit and ask you to do some conversions now. First off, if you have an xy coordinate point, you have created a right triangle with the x coordinate, the y coordinate, and the distance from the origin. If you have a right triangle, the Pythagorean theorem applies. So x squared plus y squared equals r squared is your first conversion from polar to rectangular, or between the two. What else do we know? We know that x is our cosine theta. The hypotenuse times the cosine gets the adjacent. We know that y is our sine theta, because the hypotenuse times the sine of the angle gets the opposite. We also know that Nate needs tissues. Here you go, in case you need them. These are the biggies. A couple of them that show up less often, the tangent of theta is always y over x, which also tells us that theta is the inverse tangent of y over x. These should get us through just about anything. Now, in the homework tonight, there's a mix of problems. Here is my directions for the homework, and just for getting through the homework and the next through a few exams on this. If it is possible to get an exact answer, if it's reasonably possible to get an exact answer, you have to give me the exact answer. In other words, if you're dealing with a sine of 30, 45, or 60, I'm going to want to see a root 3 over 2 or a root 2 over 2, not a decimal. Does that make sense? For some of these, that won't be possible. So even if you have a calculator, try and give an exact answer on the homework tonight. Okay? And if you miss an opportunity to give an exact answer, I will tell you tomorrow that you missed it. Now I'm just going to do examples of conversions and you'll see what I mean by that. Okay. Which would be more useful to you guys? This triangle for the relationship or those formulas? I'm going to erase one or the other.
Erase the triangle.
Erase the triangle. Not a very geometry-minded class. Okay. All right. The directions are: find the polar coordinates of each point between 0 and 2 pi and with a positive radius for these rectangular points. All right, so the first example, 0, 1. We'll start simple. Where is 0, 1 on a coordinate plane? Right there. Thank you for the pointing of it. Can you give me any sort of description of it in terms of x and y? Up. Up on the y-axis, 1 unit. Okay? In terms of polar coordinates, how would you get from the origin to here? How far from the origin are you?
1.
So r equals 1. What angle are you facing, assuming 0 is down the positive x-axis? Pi over 2 in radians. I love it. So the rectangular is 0, 1. The polar is 1 pi over 2. Any questions on that? Danny, you look suspicious.
So
Like it
then
can't possibly be that easy.
No, kind of, but then what do we do with that?
The directions just said convert the point from rectangular to polar. We're done.
That's it?
That's it for that one. Now these will get harder.
These always just stump me because they seem like first grade, like kind of math things. But just do this and then.
Well, let's get a little hard. Let's see if we can take it out of that
It
zone.
always starts easy thing. This
Yeah.
is with everything in math. It always
Yeah,
starts
but I mean,
simple.
like
We're building
last
up.
year it didn't.
All right, guys, shh, we're not having this conversation right now. Okay, now, here's where it starts getting a little more exciting. Negative 1/4, negative root 3 over 4. This one, I think I'm going to need to erase these. I'm going to need to erase these. And I'll write them back up if we need them. Okay, so I'm going to continue this example up here. I'm going to go, just arbitrarily call that negative 1/4. You guys know square root of 3 is about 1.7. So if I make this about a little more than 1.5 times bigger, whatever that is,
Kind of more or less accurate.
close enough for what I'm doing up here. So here's my rectangular point. Based on your extensive knowledge of the unit circle, is there a hint on whether or not you can find this one exactly?
3 over 4, 2.
There may be an Easter egg here, but we're looking for this length r and this angle theta. Do we give up and pull out the calculator? Yes, sir.
They're both
Multiples of 2, that's true. There's a hint in here, but let's ignore the hint for a
Wait,
second.
is it could it be 1/4 and then root 3? Because of like the 30, 60, 90.
30, 60, 90 triangle. Okay, let's take a look at the sides. This side length is also negative 1/4, right? And this side length is negative 3 over 4. Let's draw this as a triangle down here. Let's go back to geometry and lose the orientation, the positive and negative. If that were 1/4 and that were root 3 over 4, Robbie thinks we'd be looking at a 30, 60, 90 triangle. Opposite the 30 is the 1/4. Opposite the 60 is this side length times root 3 over 4. What's the hypotenuse in a 30, 60, 90 triangle?
Times
Something's doubled. Which side?
the 30.
The one outside opposite the 30.
Yeah.
Okay. What's double 1/4?
1/2.
2/4, which is 1/2. 2/8 is half. You're going the wrong way there. Okay, so because we recognize it's a 30, 60, 90 triangle, we have our radius is 1/2. If it's a 30, 60, 90 triangle, do we have enough information to find our theta as well?
Yeah.
Okay, if that's a 30 degree, that's not a reference angle. Reference angles are always to the x-axis. But if this angle to the y-axis is 30 degrees, subtract it from 270, that'd be golden. And what is that? Put that in radians for me. I'm just being a jerk, but I want to see.
Pi.
What's 3 pi over 2 minus pi over 6 going to be? And 270 minus, that's 240 by the way, 270
Yes.
minus 30, not 250, we said that. So 240,
4 pi over 3.
4 pi over 3. Someone who keeps his unit circle chart handy. Nothing wrong with that. So did we need a calculator for that? If you didn't have a calculator and you didn't spot that you were looking at a 30, 60, 90 triangle, you would then use the Pythagorean theorem between 1/4 and 3/4 to get 1/2, which would be annoying with the fractions. And if you did an inverse tangent of opposite over adjacent from here, you would get this 60-degree angle. Your tangent, the inverse tangent of root 3 over 4 over 1/4, the divided by 4 on the top and divided by 4 on the bottom would cancel, and you'd get an inverse tangent of root 3, which I hope you know is 60 degrees, and that would start help you find the standard angle that way. So if you didn't see that Easter egg, that big hint that you were looking at a 30, 60, 90 triangle, the Pythagorean theorem and your knowledge of the unit circle should still get you the right answer, just in a lot more time. Danny, you starting to feel like we might have moved out of the second grade now?
On the third, baby.
On the third, okay.
That's not there now.
All right. So we were at least getting up to 9th grade geometry, 8th grade geometry, 9th grade geometry, depending on what year you took it. Summer school geometry for one of you took it to get ahead. Any questions on that one?
Summer school?
Any questions on this? A lot going on there. I don't know if I wrote it as neatly as I could have, but
So that's how we do this?
that's how you do that one. I'm going to do one more example.
Oh, wait, so what's the final point?
This was the final point. 1/2 comma, r theta was 1/2 comma 4 pi over 3.
Why did you find 60?
Oh, I was just saying if Robbie hadn't noticed this was a 30, 60, 90 triangle, you would have had to have done something like this.
And what do you do with 60 after you get that?
I would have found that was 60, so that was 30, and then I would have done the same thing.
The one that's
Oh,
bottom
so
is
you're just trying
r
to find the
theta.
angle.
Yeah, if you hadn't noticed it was a 30, 60, 90 triangle, I'm hoping you would have gotten here and remembered your unit circle chart well enough to know that describes a 60-degree angle.
And then the 1/2 comes from where?
The 1/2, if you hadn't noticed it was, you guys got the 1/2 because Robbie noticed it was a 30, 60, 90, so you doubled the 1/4.
1/2 is the radius and 4
Yeah.
pi over 3 is the angle.
But if you hadn't remembered that relationship, you would have had to have drawn this triangle and used the Pythagorean theorem with these fractions, which would have been annoying, but should get you to the same place. Any questions here?
Do they do that now? No.
Yeah, a little bit. Well, let me show you the range of them. If you can find it without a calculator, then there's usually, I mean, think about it. Everything you know in the unit circle either comes from a 30, 60, 90, or 45, 45, 90 triangle. So the better you remember those, the less you have to keep the unit circle memorized. Everything you're expected to do without a calculator. Another example. 4 comma negative 7. 4 comma negative 7. So we're looking at a point in quadrant 4. I'll go over to 4, down to negative 7. We're looking for that radius and that theta, all the way from back here at the positive x-axis. Do you remember 4 and negative 7 being a part of any pattern?
Negative 7 or 7?
Even 7, anything. No, it's not a Pythagorean triple. It's not one a ratio you're supposed to remember from the unit circle. So for this one, I would be stuck at saying r is the square root of 4 squared plus negative 7 squared, which is the square root of 16 plus 49, which is the square root of 65, which can't even be simplified. That's just 5 times 13. And I would be stuck saying that theta is equal to the inverse tangent of negative 7 over 4, which would get me a negative, which would actually give me, if I put that in my calculator, it would actually give me this negative theta, not the standard angle, give me the negative reference angle. But without a calculator, this is as far as I'm going. So is this one, do you think, that I would expect you to give me an exact answer on? No, well, these are the exact answers. If I say give an exact answer, you leave it like this and you leave it like this. Anything else is going to be a decimal approximation because both of these involve irrational numbers. So yeah, this is where you'd leave it, or if you had a calculator, you give me the approximation. Does that make sense? Do you guys think you have the judgment for the homework tonight to know the difference between those two?
Maybe.
So maybe, we'll find out. Okay, any questions on this one? This one's very straightforward and simple in a way. Just use the geometry. You don't, if you remember your geometry well enough, you don't really have to memorize those conversions. Okay, now I'm going to give you the polar coordinates. You're going to tell me the rectangular. Are you ready? No, not at all, Diego says. Okay, so is that right? Yeah. 1/2 3 pi over 4. This is another example. Okay, now we're back into polar. And I want you to give me the rectangular. So if a graph will help, where's 3 pi over 4? How many degrees is that?
3 pi over 4 is down.
Where's that unit circle? Which quadrant is it in? What's pi over 4?
Pi over
45. What's 3 times 45?
Oh, wait a minute, that's 135.
135. Or even if you can't remember that, here's 0 degrees, here's 45, then 90. So another 45 degrees will take you halfway into quadrant 2. 3 pi over 4 is 3 times pi over 4. So it's 3 times 45. That's a hint I used to have some idea where I am. Okay, so, and it's got a length of 1/2. What kind of triangle have I created here?
45.
Yeah,
Yeah, 45.
keep going. This is a 45, 45, 90 triangle. So if we go back to if we go back to geometry, we're looking at this situation, a 45, 45, 90 triangle with a hypotenuse of 1/2. So,
Just make it 1/2 of the square root.
that is going to be annoying, isn't it? Good memory. What's the pattern for a 45, 45, 90?
The 2 legs are the same.
2 legs are the same.
And the hypotenuse is the square root of the legs.
Square root of 2 times the length of the leg. So I remember it as 1 to 1 to root 2 is the ratio. It's kind of annoying with a 1/2, isn't it? Okay, so if this is a 1 to root 2 ratio, how do I go from 1/2 back to here?
Root 8.
No, oh, we're not squaring though. Good. It's a ratio, so it's either multiplication or division, not exponents. So if you multiply by square root of 2 to get here, what do you do to go from the leg to the hypotenuse? We multiply by the square root of 2. It's a ratio.
Divide.
So to go from the hypotenuse back to the leg, we go 1/2 divided by the square root of 2. Does that look like a satisfying or acceptable way to leave your answer?
Yes.
No. 1/2 divided by the square root of 2 is the same thing as 1/2 times 1 over the square root of 2, correct? So that's 1 over 2 root 2. Am I allowed to leave that in the bottom? No. Multiply top and bottom times square root of 2 to rationalize my denominator. Root 2 times root 2 is 2. Times another 2 is 4. 1 times the square root of 2 is the square root of 2. So it looks like this is going to be the point negative square root of 2 over 4, comma, positive square root of 2 over 4. Negative because now, here's the geometry version. Now we go back to the precalculus version and we have to take into account that going to the left means negative, going up means positive. So this is the point negative root 2 over 4, comma, positive root 2 over 4. That wasn't the only way to do that one, I don't think. But I always like to go back to the geometry. Could we have done that? Would that have been harder or easier with the conversion formulas? Let me know when I can erase this drawing and I'll show you the other way to think of this. You guys ready? Up with this? Good note takers? Okay. Let's say we've gone right to the formulas. X equals R cosine theta. Cosine 3 pi over 4.
Oh, yeah.
So that would have to be negative. Now, but you should remember from the unit circle that the cosine of 3 pi over 4 is the opposite of the cosine of pi over 4. It creates a 45-degree reference angle in quadrant 2, and in quadrant 2 the cosine is negative. What's the cosine of pi over 4? So this is negative 1/2 times root 2 over 2, or negative root 2 over 4. That's if you use the conversion formula. Also, if you use the conversion formulas, yep, y is r sine theta. So that's 1/2 sine of 3 pi over 4. Sine of 3 pi over 4 is exactly the same as the sine of pi over 4. It's a 45-degree reference angle in quadrant 2, where the sine is also positive. So this is 1/2 times root 2 over 2, or positive root 2 over 4. And this gets you your x coordinate and your y coordinate using the formulas. What are some advantages and disadvantages of each way of doing it? What's the advantage to the other way we just did?
If you don't have a 45 or...
Well, I was thinking for this specific problem, with this one. The advantage of the other way, for do it the way I first did it, with going back to the geometry, did you need to know these formulas at all? I didn't use these formulas. We just used the fact that it was a 45, 45, 90 triangle. You had to remember your geometry, but you didn't have to remember this or this specifically. If you do it this way, you have to remember these formulas and you have to remember your unit circle. Which is better? I don't know. I honestly don't have a preference. But I want you to understand both, and when it comes to the homework or test, you pick. Might be easier to go through the formulas. I don't know. Which did you guys like better, drawing the triangle or this?
Well, if you have a...
Yeah, formulas.
If you have an easy triangle, probably the triangle. But it's not a 45 or 30, 60.
Well, if it's not a 45, 45, 90, or 30, 60, 90 triangle situation, you're going to have to pull out your calculator anyway. So, yeah, it just depends on which you remember better.
Formula is easier because drawing the triangle always takes too much time. And you always get worried if it's not good looking enough.
Okay, that never bothers me, to be honest.
No,
but-
I mean, like, it doesn't have to be beautiful, but like, if it's supposed
No,
to
it's
be
gotta be
60,
accurate.
90, and it's like way off, you gotta redraw it. So
That makes
you gotta
sense.
do yourself.
I can see that. All right, let's do another one of these. And I'll let you guys pick whether we go right to the formulas or not, or if there's a different way to do it.
Oh, we're doing another example.
Yep. That's all we're doing today's examples. But we're going to get to the graphs in a second.
Oh my god, no.
-2, 270 degrees. In polar this is in polar coordinates. What is that rectangular? Well, first off, where is that? So Danny, I'm very visual. I never mind drawing anything.
Alright, keep going.
We go up after
Very good, Diego. We go around to 270 degrees, but then from here, we go up 2 units. Do we need to pull out any formulas or anything to tell me where that is in terms of rectangular coordinates?
No, it would be,
Where would that be?
0, 2.
Boom. 0, 2. Polar to rectangular. So there's another strategy. If it's on one of the axes, don't pull out any triangles or formulas at all. Would the formulas work? Yes.
It's going to be so much longer.
Yes, I agree. You guys think you can handle ones like that? Maybe?
I
That's
forget.
the-
I thought it was
that
a
should be.
2,000 something, whatever.
Oh, 2,270 degrees? Yeah, you got to be careful with that. That's honestly yet another reason I prefer radians. What would you say, Robbie?
So that's the whole test.
The whole test should just be one or two of these. That would be nice.
I think the whole test should be like
I know, chill. Okay, I'm going to erase
grade.
this one. And now we're going to jump to equations. Example, y equals 5. That's a rectangular equation. It's a horizontal line. Give it to me in polar form. Here's where the conversion factors come in.
R equals 5. No.
Y equals 5 is a circle.
R equals sine.
Slow down, Cowboy.
No.
What does
5
y equal?
5 equals.
What does y equal in general? In the conversion from rectangular to polar.
Sine. How goes it?
No.
Y lines up with sine,
Sine.
but you're leaving out something.
It's
Theta.
No, it's the R.
R sine theta. This is your y conversion formula, right?
Yeah.
So anywhere you see a y, put in a sine theta. So this is r sine theta equals 5. Now, at this point you have followed the directions. You have created a polar representation of this idea. But, remember we talked a little bit about polar functions. Just like rectangular functions are always y equals, polar functions are always r equals. Solve this for r. Danny? What do I do?
I was going to say, you got to sine.
Inverse.
Actually, we don't know. Never mind, I was going
5 divided by
to say something, but we don't actually know the angle.
Diego
around.
finally tripped over the simplest way. We're going to divide both sides by sine theta.
Oh, so this is like the thing we did before break, kind of?
A little bit, yeah, where we're solving the trigonometric equations.
Are they?
Now, your book, most back of the book answer sections, I don't think polar coordinates are many standardized tests, but if they are, don't usually leave it as 5 sine theta. Usually, what is the reciprocal of sine? That's how they rewrite it. Remember this from right before break?
Secant.
Cosecant. So this theta would be r equals 5 cosecant theta would be the final form of your answer. How do you write y equals 5 in polar coordinates? You've answered the question really the moment you put in r sine theta for y. But that's not elegant. If it is a polar function and you can get r by itself, you should.
So
How did you
you're just converting equations here, Matt. So
Correct. There's no solving for anything. And remember, this is a polar graph. So I mean, this is a rectangular graph. This is its polar graph. There is no one solution. It's all the infinite number of points that have a height of y on the Cartesian coordinate plane, no matter what x is. If you think about that, that's a very simple idea. This is one of those cases where the Cartesian coordinate plane has an advantage. That's a very simple idea in the algebra you guys have been learning. I don't care what x is. Its height is going to be 5. That's not too complicated, is it? X is 1, y is 5. X is 2, y is 5. X is negative 50, y is 5. Think about how complicated this gets in polar coordinates. Everything is described now in terms of the length of a radius and an angle theta. Here, y is just staying 5. Here, if I change this angle, I get wildly different lengths of radius. R goes from 5 to infinity in both directions as theta goes around the circle. Quick conceptual check. How is it possible for this polar function to represent this horizontal line when angles are past 180? If theta goes to there,
They somehow curve around.
that's
How can
has
it-
to be negative.
yes, every time theta is past 180, we must get a negative radius to represent points back up here. Hey, what happens to sine when it goes past 180? down below the x-axis. It goes negative. So it makes sense that this line would have a sign in its representation. Since sine is negative from 180 to 360,
But it's positive from here.
positive from 0 to 180, yep, and we need all our points up here. So you can just, this really can help you understand how polar equations work. Also, polar equations are not better than rectangular equations. This is a much more complicated way to represent this idea than y equals 5.
Yes.
But if you're talking about circles or spirals or a couple of other shapes, oh my god, polar coordinates are so much easier.
And you do a spiral
In rectangular?
Yeah.
You'll tell me in a second. The
We'll
simplest,
tell
yeah,
Oh, God.
the simplest
You
spiral.
just put dots around and you can connect them with lines.
Well, hold on. That's your simplest spiral, right? R equals theta. As theta increases, at 0 you're at 0. At pi over 2, you are actually at approximately 1.57 at a 90-degree angle. At pi degrees, you're at approximately 3.14 on this axis. So that's the simplest way to get your spiral going, right? How would you do that? Well, r squared is the square root of x squared plus y squared. Theta is the inverse tangent of y over x, right? Whoops, r squared equals x squared plus y squared. I was skipping ahead to something there. So obviously r equals theta is, here's what I was thinking of, the square root of x squared plus y is equal to the inverse tangent of y over x. Does that look like a fun equation to manipulate?
Wait, why is the y not squared?
Because I left the exponent off by mistake. Thank you for catching that, Remy.
Where would we be without our?
I would have a lot of mixed up exponents and positives and negatives. Which would now, this creates all sorts of problems with positives and negatives. If you go on your calculator, remember this, your calculator only gives you half the possible ranges for this. So this probably wouldn't even work. I've never really tried it. This scares me. This is a lot easier. Which would you rather manipulate in general? This or the rectangular?
First one.
Yeah.
I'd write this.
Yeah. So which is better, rectangular versus polar? Depends on what you want to talk about. Other things are, if you, oh my god, if you want to translate, if you want a circle to not be centered at the origin, polar coordinates actually become a pain.
Wait, who made the polar point?
We're going to talk about that a little bit more tomorrow, in how a lot of these things have their ideas. I'm not sure who formally decided to call it the polar plane and finalize it, but the ideas upon which the polar plane are based all go back to the unit circle and a couple of other ideas that started in the late 1500s, and we're actually going to talk about that a little bit tomorrow.
So we're gonna have history also.
Yeah. Yes, yes, yes. Okay. Let's give you a, in fact, let's take a look at, well, some of these are bad. Now, because of the order in which we're going in this course, I don't know. Yeah, another example, thank you. I don't know if you guys know what this means here. Does anyone know what that graphs in rectangular coordinates? You may not have gotten to this in Algebra 2. Let me give you a hint.
It looks familiar, but I mean a lot of those kind of
Did you get to learning what this meant in Algebra 2 last year?
Is that a forward thing?
Wait, I recognize that, I think.
Okay, in
Yeah, kind of.
the Cartesian coordinate, this is your equation of any circle centered at the origin. We're going to get to this in a little while. We're going a little bit out of order on this, unfortunately. This is any circle centered at the origin, and the radius is 2. This number is always r squared. Looks just like your conversion formula from polar to rectangle. X squared plus y squared equals r squared. That's actually your equation for a circle in Cartesian form. Remy, is that what you've remembered seeing before as a circle?
Wait, maybe.
Okay. We'll get a little more detail into this later, but this one with this -2 in here, This, guys, is just a counterintuitive shift of y, counterintuitive shift up 2. So this is the same circle. X squared plus y minus 2 squared equals 4 is a circle with a radius of 2, and it's centered at 0, positive 2. That's not what the directions say. You don't really need to know that, but that might help. The directions say convert this to rectangular. Any ideas how we're going to do this? Okay? Any ideas how our formulas are going to work on this? Do we have a conversion formula for y minus 2? Or do we have one for y?
Yes.
Yes, maybe. We do have one for y.
R equals
R sine theta.
what are R?
Usually these are easier if you FOIL first. So I'm going to rewrite this as x squared plus y squared minus 4y plus 4 equals 4. Any questions on how I FOILed that? I hope not at this point in your math careers. What's x?
Oh, I see, there's a y
Okay.
in the parentheses.
Okay.
I was looking at the x squared plus y squared.
Yeah, sorry, this one, I just wanted to see if any of you guys remember this was the equation of a circle or had seen that before. It's good for me to know if you
It was
haven't.
like the color was.
Yeah, ignore that. I shouldn't have gone there. Okay, x squared plus y squared. Is that anywhere on your conversion formulas for polar? You can ignore this whole part now, actually. Sorry. If you guys had studied how this is a circle, that would have been helpful, but you haven't, so it wasn't.
X squared plus y squared is r squared.
X squared plus y squared is just r squared. Robbie, you just said y is r sine theta, right? Correct? Okay. Incidentally, I can also subtract 4 from both sides. Anybody catch that that was possible?
See that?
So this gives me r squared minus 4r sine theta equals 0. I am now going to add 4 sine theta to both sides, and it gets me r squared equals 4r sine theta. I am now going to divide both sides by r, and I'm left with r equals 4 sine theta. Apologies for the rushed algebra there. We're almost out of time. Any questions on that? Have I successfully converted this into a polar function?
Yeah.
Yeah.
Incidentally, if you remember your patterns,
That seems so much simpler.
depends on your algebra skills. This is one of the patterns I asked you guys to know 2 days ago, 4 sine theta. It is a circle. The circle is tangent to the origin. It goes up the y-axis and has a diameter of 4. It goes up the y-axis because it's sine and it's positive. This is also the same thing as a circle, centered at 0, 2 with a radius of 2. So that does check, but you guys don't really know how to double check that yet. We'll get to that after this unit. Any questions on this?
Nope.
Okay, your homework tonight is over here, written on, it's page 572. 14 to 36 even. Now, I don't know for certain that I've covered every single thing you'll encounter, and I didn't give you one strategy that'll work on all of them. That second part's intentional, that you don't have one strategy that'll work on all of them. I want you guys to decide which works the best. Straight up algebra conversion, drawing a triangle, remembering the unit circle, spotting some other hint, clue, or Easter egg. I'm curious what you'll come up with tomorrow.
Or the next
What was it?
magical one that you haven't told us yet.
Or the next magical one that I haven't told you yet. That's possible.
What was
All right.
the physics homework?
I'm not sure. Hang on.
You didn't, oh yeah,